don't think about exponential growth as, oh, it's AB to the x, and I'm going to plug in and crank out values. No, you want to think about how does the output grow. It grows by repeated multiplication by a growth factor, right? Repeated multiplication by the growth factor. So growth factor is a multiplier on output to get another output. Remember the first day we said exponential growth is a very specific type of growth. Very specific. It's not just that the amount accelerates off to infinity. And it's not just any curve. It's very specific. The output grows by repeated multiplication by a growth or decay factor. So if there's one thing you learn in this unit, it's this. This is the one thing I would want you to learn in all of Module 4. Okay? And then what stays consistent? Percent change, right? So if you have a multiplier, then you have the same percent change every time. So let's talk more about percent change. Okay? So we know we have the 1 unit growth factor. That could be decay factor too, just for our purposes, I'm calling it a growth factor. And we know that from the one, we usually call that B, and we know that we can easily get other growth factors from the 1 unit growth factor. What's the 16 unit growth factor? B to the 16. What's the 1/2 unit growth factor? B to the 1/2, right? The 1/8 unit growth factor. B to the 1/8, okay? So given a growth factor, these are easily transferable between other growth factors. Growth factors are directly transferable. Question?
Is another way to write that this like the 8 square root d thing? The 8th root, I think it's called.
Yeah. So the 8th root.
Okay.
Yeah. So that's just a little more cumbersome. But yeah. So the square root, it's like a square root symbol, but with an 8. It's at the 8th root of b. Yeah. It's the same thing. Okay. So what about percent change? Percent change directly transferable like this? All right, let's investigate it, okay? So we know we get the 1 unit percent change from the 1 unit growth factor, right? Similarly, we know we can get any particular unit percent change from its corresponding growth factor. We've seen that. Okay, but what about, is this transfer? Do we have a transfer between percent change, the way that we have this direct transfer between growth factors? Okay, so suppose the 1 unit growth factor is 1.25. Okay, what's the 3 unit growth factor? Find it. Go. Find the 3 unit growth factor. Okay, how about Sean? This Sean. Did you get it?
Yeah.
What is it?
1.95.
1.95. Did you guys get that?
Yeah.
1.25 cubed is 1.95. Okay? What's the 1 unit percent change then? How about Faisal? What's our 1 unit percent change? 25%. Increase or decrease? It's 1.25 is our. So we're increasing by 25% every time we advance 1 unit. Are we advancing 1 unit in input or output? Are we advancing 1 unit in input or output? Input. This thing refers to the input that changes when you multiply the output by that factor to get the other output. So you're still multiplying an output by a factor to get another output. But now this tells us what advance in input corresponds to that, right? So 1 unit means that a 1 unit advance in input, okay? To get that new output. Is there a question? Is there a question? No. Okay, so what is so 25%, what's the 3 unit percent change? Yeah.
95%.
95%. So what about it? Is it times 3?
9.
Sean?
No.
No, right? 25% times 3 is 75%. Okay? Why not? What's happening? Michael?
This is something to do with it being the actual like percent change in there, so you're dealing with change percent rather than actual. I was looking for words anyway.
Okay. So what's the reason that you can't just multiply the 1 unit percent change by 3 to get the 3 unit percent change? Yeah.
Is it because it's not a constant rate of change?
Okay. And so what's happening? That's true.
So you're not multiplying it by 3, but you're multiplying it by itself 3 times.
Okay. And why? So right, that's true. And why does that result in it's a higher percent change than 3 times 25%. Sean, what do you think? Why does it not work that if you multiply 25% by 3, you get the 3 unit percent change?
Because that's not what it's asking you to do. It's asking you for the per day value, well, the per unit value instead of, because you technically don't have, 3 is the input to the 1.25, and the 1.25 is the multiplier.
I don't think you understand the question. So, anyone have an idea? Why does multiplying 3 times 25% not give you the 3 unit percent change?
Because that's not multiplying the growth rate, that's just multiplying the original product. What's increasing is the rate of growth.
Okay. All right. Any other ideas? Yeah.
3 units grows more than 1 unit, so it's not like. Well, I don't know.
So what happened after 1 unit? We grow by 25%, right? So now we have a larger value than we had before, and now we're going to take 25% of that. So what about the amount of increase from the second to the third unit? We're taking 25% now of a larger number rather than the original number. You see? So you're not taking 25% of the initial amount and adding that each time. You keep taking 25% of a greater and greater value. So you have what's called a compounding effect, right? You have the 25% of the original plus 25% of the increase. So you get a percent on that percent increase. So that compounds and results in a greater overall percent change than 75%. In this case, 95%. Okay, so the moral of the story is percent change is not directly transferable. All right? But we have a roadmap now. We understand how we can get 1% change from another. Okay? So if the 1 unit percent change is 2.5%, what's the 16 unit percent change? So, first of all, can I multiply 2.5 times 16 to get this? No, but what can I do? So we can map out a roadmap here. And so here I am, where am I going to go first? Just stay on the road and you can make it. So we're trying to get to here. So what am I going to do first? Freddie? Multiply by what? No. Yeah.
Subtract 1 and divide by 100 to get your growth factor.
Okay, so we want to find the 1 unit growth factor.
And then you get 0.35 and then put that to the
0.35? 0.035? No, I think you didn't get the right growth factor there. So if our 1 unit percent change is 2.5%, what's the 1 unit growth factor? Nathan?
1.025.
1.025. That's an increase, right? So that's 2.5% increase. And now what? Now what, Freddie?
Do
Subtract. What do you think? Are we going to subtract? Where are we trying to get to? We're trying to get to the 16 unit percent change. And we're at the 1 unit growth factor.
Oh, maybe like that. Like the over 60.
Take to the, and that will give us what?
So, the 16 percent.
Yeah, no, not the 16 unit percent change. We can't go straight from here to here, right? We need to get the 16 unit growth factor first. So you just stay in the road, right? So 1 unit percent change, get the 1 unit growth factor, get the 16 unit growth factor, and then we can get its corresponding percent change. So how do we get the 16 unit? Yeah,
Take 1.025 to the 16.
to the 65, that's right.
You get 1.485.
1.485.
And then you subtract that by 1. You get 0.485.
Okay,
You multiply that times 100, you get 48.5%.
48.5%. Right, a lot more than 16 times. 16 times 2.5 is what? 40. But instead, you get for 16 units, you get 45% increase. 48.5% increase. Okay, so to get any percent change, you need to have the corresponding growth or decay factor. And so that means get yourself on the road of growth factors and decay factors, and then get the one you need, and then find that corresponding percent change. So our roadmap, percent change to growth factor to percent change. Okay. Here you go. Go. 3 unit percent change is 79%. What's the 1/2 unit percent change? Jacqueline, you got it? Tell me.
10.2%.
Well, process always. Never final answer. Process. Tell me what you were thinking, what you did.
Okay, so I took 79%, to the growth factor which would be 1.79.
She's saying the 3 unit growth factor is 1.79. Okay.
And because I like skipping steps, I did both. I brought it to the power of both 1/3 and 1/2. So entirely
Okay.
would be to the power of 1/6, which would bring it to the 1/2 growth factor. Which
Okay, hold on. So let me just catch up with you there. So what she's saying is she knows how to get directly to the 1/2 unit. If you want to always go back to the 1 unit, that's perfectly fine. But she's saying you can get right from the 3 unit to the 1/2 unit by doing 1.79 to the what? Was it 1/6? Right, because it's going to be 1/3, and then you take that to the 1/2. 1/3 will take you to the 1 unit, and then 1/2 will take you to the 1/2 unit. The overall effect of that is 1.79 to the 1/6. Okay, now keep going.
which is 1.102,
Good.
which will bring me to a percent change of 10.2%.
Someone else get that? You guys agree? Yeah, cool. Questions on this? Yeah, so you're perfectly welcome to always go to your home base of your 1 unit growth factor. So that would be 1.79 to the what? 1/3. And then you would take that, and you would take that to the 1/2. So that's the same as 1.79 to the 1/6. All right, cool. Next one. The 1/5 unit percent change is negative 1.8%. What's the 10 unit percent change? Go. Decay is a little harder. Gotta know your stuff with decay. What's up? How about Cameron? How'd it go, Cameron?
Well, I'm not done yet, but I would, first you have to change it so that it'd be like 0.018. So I did, and then subtracted that from 1
Okay.
to get 0.982. And that would be the decay factor.
Okay. That's the 1/5 unit decay factor.
Yeah.
Cool.
And then that's the power 15.
Okay.
Get the 10 unit growth factor. Which I don't know what that is.
So again, you can go straight to there, or if you need to go to the 1 unit, what would it be to get the 1 unit decay factor? Allah, how would we get the 1 unit decay factor from that?
Well, I'm not sure, but I subtracted 1 minus 1/5, which gave me 0.8. So we will raise the 0.98, the 0.8 to get the 1 unit.
Nope. If this is one, how many 1/5 units give us 1 unit? That's what we're asking. How many 1/5s? So we're going to keep multiplying by 0.82 every 1/5 unit. How many times would we need to multiply then to get to 1 unit? Be 5 times, right? So this would be 0.982 to the 5th. I think that's different than what you said, is it? Yeah. Does that make sense? And then from here, if that's the 1 unit decay factor, how do we get the 10 unit decay factor?
Okay, then we are going to, once we get the result, we are going to raise it to the second.
From 1 unit to 10 units?
Oh, well, ordered right. So the 0.982 to the 5th is the 1 unit. The result is going to be raised to the 10th.
The 10th, right. And so that's how Cameron came up with to the 50th. 5 to the 5th here, and then that thing to the 10th. All right, Cameron, keep going. What'd you get?
So then after you get that, you change it to percent change. First you have to subtract 1. Subtract that from the answer from 1.
Okay.
And then move the decimal over.
Okay. What is 0.982 to the 50th? 0 point. Tell me. Anybody got it? 0.473. Someone else got that? 403?
Yes.
We good now? So the 10 unit percent change is negative 59.7%. Question? Yeah.
Is this correct, by the way?
I'm asking. Yes, I think so. There was seemed to be confirmation. Other people get this? Yeah, I've got lots of nods. Was that the only question?
It's just that, like, oh.
You're good?
Yeah.
Other questions? Okay, here you go. The 1/2 unit is negative 34%. What's the 1/8 unit percent change? Okay, who's up this time? Jonathan, how'd it go?
So first I subtracted 34%.
Okay, good. Okay.
And then from there, I took that to the line.
Yeah, totally valid. So he did 1/2 unit, and he found his 1 unit growth factor, and you're going to take that thing to the what? So the 1 unit growth factor to the, you said 1/8, right? Yeah. And if you went right from here to here and took it to the 1/4, that's the same thing. Took 0.66 to the 1/4, totally valid. But either way, it's great. Okay. What's that value? 0.66 to the 1/4. Anybody? Shout it out.
0.901.
0.901. Okay? 1/8% change. Yeah, did you get it?
Negative 9.9%.
Negative 9.9%. Agree? Okay, so again, we've seen the growth and decay factors are the key to this. They're easily transferable. To get a percent change, it has to come from the corresponding percent, or percent. To get a percent change, it has to be from the decay or growth factor that matches that. Yeah.
Just asking, so like we have to like get it back to the 1 unit growth factor before we get to the 1/8, right? Because what I tried to do was I tried to multiply it by once, not multiply, but like to the power of 1/6. And it gave me something close, but the result I needed. Negative 93.3.
But something to the second and to the 1/8 is not to the 1/6. So your approach can work. You just picked the wrong exponent. So 0.66 squared and then to the 1/8 is the same as 0.66 to the 1/4, not 1/6. So you can go directly from here to here, but 1/8 is 1/4 of a half.
Yeah.
You don't subtract. It's not. Yeah, you don't. 1/6 does not come into play here. 1/8 is 1/4 of 1/2, so you're going to do 0.66 to the 1/4, and then you get the 0.901. Other questions? Okay, so we're going to start talking about money. So here's a warm up to that. If the 1 year percent change is 9%, what's the 1/4 percent change? Meaning every 3 months. If the 1 year percent is 9%, what's the 1/4 percent change? Lead me through it. Let's see. Abdullah, can you lead me through this? Did you follow the previous examples? What we just did? All those examples? It's very similar. So 1/4, we're taking 1/4 of a year.
First of all, it's 1.09.
1.09. So this is kind of like, this is like 1 year, right? So this is like 9% every year. So you're saying 1.09, then what?
To the 1/4.
To the 1/4. So it's kind of like we're talking about the 1/4. $1.09 to the 1/4. What is it? Anybody, shout it out. 1.0217.
Yes.
Perfect. 1/4 unit percent change then. 2.17%. Again, not 1/4 of 9%, right? Not 1/4 of 9%. 2.1% over 4 quarters. The interest, the percent increase on a higher and higher amount will result in a total increase of 9% over 4 quarters, or 1 year. Okay, so keep that in mind, okay? Remember that. We're going to come back to that. Uh-oh. This will be fast. Oh, we got one more. Ugh. Okay, what about the 1 month percent change? So we're going to take that 1.09 and do what now? We want the 1 month percent change. It would be the one what? What fraction would be, Carlo, if we want the 1 month? For a unit is a year, 1/12, right? So we're going to do 1/12 and 1/12. So we're going to do 1.09 to the 12th. As soon as you get it, tell me. 1.0, 0, 7, 2, percent change, 0.72%. Results in 9% over a year. So increasing 0.72% every month is equivalent to 9% increase every year. Okay, so let's talk about APR. So you guys will be buying cars, you'll be buying houses, and you'll be most likely taking out a loan to do these things. Okay? It's the culture we live in. Unfortunately, we're at a debt-driven economy. Okay. All right. So APR, often used when loans and investment, is different from the 1% change. So let's see how this works out. So I think we already did this, right? Did we see if the 1 year percent change is 9%, the 1/4 percent change is 2.18%? Is that right? Okay, but if you get an APR with what's called quarterly compounding, then look what happens. The 1/4 percent change is 9/4 or 2.25%. Right? So this is absolutely breaking the rule that we just emphasized for the last 15 or 20 minutes, right? It's taking the percent and dividing it by 4. Do you see? APR is the exception to this thing. Okay, so when you're dealing with APR, it's different. You actually, if you want quarterly compounding, you actually divide the annual rate by 4. Same with the 1 month. Well, we found that the 1 month percent change was 0.72, right? But the APR is going to be 9/12, 0.75%. So is this good for you or bad for you? Well, it's bad if it's a loan, right? If it's a loan, then instead of paying 2.18% per quarter, you're paying 2.25%. But if it's an investment, well, this is good, right? Yeah, please.
Doesn't that mean that at the end of the year it's not actually 9%?
That's right.
Wouldn't that be? Isn't that lying?
No, so there's actually a form, like when you buy a house, there's actually a form. You have to sign a zillion forms. One of the forms you have to sign is that you understand that very fact that you just said. That if you're getting an APR with a certain compounding, your actual percent you get per annual is different. It's different. And there's a form that you sign that says you understand that.
People don't understand that.
Right? What's that?
Most people don't understand.
No, that's why they have the form. You're supposed to read the form. You just don't sign anything you haven't read. Right? Okay. So let's do this. Okay, so with APR, you begin by finding the rate by straight division, which is, we said you don't do, right? All along we said you don't do that. You find the growth or decay factor first. Find the rate growth or decay factor and find the percent change from that. But with APR, you do. You do straight division to start with. Okay? But then, after you do that division, now from here on out, from this point on, you follow the rules. So now if you want to go back and find the true percent change per year, what would we do? So I've got 2.25% per quarter. That's a true percent change. So what's the true percent change per year? How would we do that? So Nick, what do you think? How would you find that?
Which one? The
So that now we're back to the same deal we did before. If we got 2.25% increase per quarter, what will be the corresponding percent increase per year? How would we do that?
would be 2.25. Well, the point 0.0225
Okay,
to the power
to the power of 4.
4 or 1/4.
What are you going to raise to the fourth power? So you got the right idea, but it's not going to be
I want to raise the growth factor.
right. What's the growth factor?
Wouldn't it be 1 plus the percent change?
Right. That's not. Yeah, you haven't said that yet.
Oh, I thought I said 1.
You said 0.0225 to the fourth.
So 1.0225.
Right.
Am I saying that right?
Yep.
Okay. Then to the power of 4.
Okay, so we're going to take 2.25% per quarter means what growth factor? 1.0225. So we want to find the annual growth factor, 1.0225 to the fourth, which is what? 1.093? Give me two decimal places.
308.
308. Someone else get that?
Yeah.
Yes. So what's the if you have 9% APR with quarterly compounding, your true percent increase per year is 9.308%. So, does it make sense? All right, so you find the true percent increase when it's 9% with monthly compounding. So find the true percent increase when it's 9% with monthly compounding. So now this is just like all the examples we did before. All the examples we did before with percent change and factors. Aaron, did you get to do it?
What did you ask?
So given an APR with 9% with monthly compounding, what's the true percent change per year? It's not 9%. So how do we get the true percent change per year for 9% with monthly compounding?
Can you do like use the same amount on the bottom, but instead of quarter, do the month?
Okay. So what is it per month? Not sure. John, did you get it? 0.75. So 0.75 is per month. So what do I do? 1.0075. And what is that number? What does that number mean? For? Growth factor for what? For 1 month. That's the 1 month growth factor. Okay. Then? To yearly what? Right. So we're going to take that to the 12 to get the yearly growth factor. 9 point. 380 this time. Someone else get that?
And yes.
So everything's the same except for the first step. When you're given an APR with certain compounding, you start by finding the true percent change for that period, that whether it's a quarter or monthly. But once you have that, then you follow the rules. Okay? Then you follow the rules. So once you have that percent change for, say, 1 month, 1 quarter, 1 day, whatever it is, 1 half year, then you follow the rules and you work back to, using growth factors, you work back to the true percent change per year. Okay, does it make sense? Yeah.
How would an investment house be different?
What's that?
You said something about an investment house. How would it be different? Would you balance it?
It benefits you if you're making an investment. So if you're investing at 9% with quarterly compounding, your return on your money per year is going to be more than 9%. It's truly going to be 9.308%. So you're getting a greater return than 9%. So that's how it would benefit you. But if it's a loan, then you're actually, if it's an APR 9% and it's a loan, well then you're paying more interest, right? You pay interest if you have a loan. But you get interest if it's an investment.
But you meant investment home.
What's that?
But you meant an investment home.
No, okay, no. So yeah, if you have an investment home, you're still paying and getting a loan.
Yeah.
So no, so if, yeah, it's still, you're still paying the higher rate. Okay, so what that's called is those two numbers that we got, the 9.038 and the 308 and 9.38 or something. Those are called APY, annual percent yield. APY is the true rate of return, or the actual increase per year for a given APR in the compounding scheme. Okay? So find the following APYs. You got 4 to do there. So an APR of 7.5% compounded semi-annually means what? What true percent increase or what APY annually? Andrew, did you get the first one? Talk me through it.
So first you find the growth factor for it, so you divide it by 100 and add 1.
What are you going to do?
First you find the growth rate for it, so to get the percentage you divide it by 100 and then let the
Oh, let's see.
rate you add 1.
Yeah, but that 7.5% is not a true percent. So you're not going to find a growth factor for that. What do we need to do first? So that's an annual rate, but that's not a true percent. That's this thing called APR. So what do we do first? What true percent do we know from that? Do you remember? The first step is to do what? What do we have to do first? No. Look at yeah, first you have to get the per semi-annual rate. And this is where you break the rules. That first step is where you break the rules. You just take that 7.5% and you divide it in 2. You say 7.5% for 6 months. And what is that? 0.0375. Now that's a true percent change for what time period? That's the true percent change for 6 months. So now from here on out, we follow the rules. We use growth factors and percent change just like we have before. But this is the one step where we break the rules, right? That's what the nature of APR. So we got 0.0375. So Andrew, what from there? I'll try again.
Yeah, alright.
Add 1 to that. And what's that number mean? 1.0375 is what?
And now that one is the growth factor for or growth rate for 6 months.
Right, that's the growth factor for 6 months. Good.
So you square that one to get the yearly one,
Yep.
and then you subtract 1,
Well, what do you got? 1 point.
1.076.
Let's do one more decimal place. 7 what?
764.
6.4? Okay.
And then you subtract by 1 to get the decimal form percentage,
Okay.
and then you multiply that by 130%.
Okay. Or you can just declare it. What is it?
7.64%.
Yeah. So 7.5% compounded semi-annually is a true APY. The true yield every year is 7.64%. Doesn't make sense. Does that make sense? Okay, let's just do one more of these. Anyone have a request? What's that? The last one. Okay, so the last one, what do we do first? So 18% is not annual. Yeah, you can take 0.018 by 365, ignore leap year, and we get .0. Call it out if you got it. Nice and loud. 049? 0049. 00049. Okay? And what are we going to do with that? So what's that number about? Let's see. How about this, Zach? Did you work this one? Mm-hmm. Add 1. And what does that number mean? 1.00049. What is that number? How would you interpret that number, the 1.00049? What is it? The growth. You gotta be more specific than that. The what? Okay, but remember, in a search situation, we have lots of growth factors. Which growth factor is this? Right, we have like 1/2 unit, 4 unit, 10 unit. All those are growth factors. So which growth factor are we talking about here? 1 day or daily. The 1 day or the daily growth factor. What are we going to do with that? We want to get what? Annual percent change. Annual true percent change. So what do? Raise it to the? Yep, we want to get the, so first we'll get the annual growth, the true annual growth factor. So hopefully, if we kept some more decimal places than just the 49, raise it to the 365, and we get 1958. So is that, if I round the 7 to 8, does that work? APY. Over 1.5% greater. So what do you notice about the effect on the APY for compounding semi-annually versus compounding daily? Yeah, so the idea is, so this compounding semi-annually just means you're going to calculate the amount at the end of 6 months, add the interest in, then do that again at the end of the year. So you only kind of add the interest in and build interest on interest once. Here you're adding interest on interest every single day. And so this is a compounding effect. The interest on interest grows. And so the more often you compound, the greater change your APR is, the greater change to your APY than your APR. Yeah, Michael?
So is there a reason that they're presenting the other percent? Is it just kind of a tricky thing that they do?
I don't know where it originated from. I don't know where it came from, but it's what we use. I mean, you hear it on commercials all the time, right? 1% APR, blah, 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 right? So just know that that's not your true rate. That's the point. The point is that's not your true rate. You have to do the math to get the true rate is the APY. But I don't know where it originated. I need to do a little research on that. Okay, so suppose you make a 15% APR compounded monthly. How much will 10,000 be worth after 7 years in this scheme? How much will $10,000 be worth after 7 years? Can you do it? So 15% APR compounded monthly. Okay, and so as you go through the steps, identify every number that you're calculating along the way, like I've been trying to encourage you to do. So don't just try to say, this is what I'm going to push to get a final answer. Take through the process, identify what you're doing, and identify the meanings of the numbers through the process. Sean, do you think you got it?
Yeah.
You take me through it?
Okay, so first you have to take the 15% and make that 0.15.
0.15.
And then you divide that by 12 since it's compounded monthly,
Okay.
which will give you the monthly growth rate, is it? Or no, sorry, you have to add 1 first and then
Okay, so you're going to add 1.
Yeah.
And that whole thing is the
monthly growth rate.
monthly growth rate. Is that right?
Growth factor. sorry.
Monthly growth factor, right? 2 different things.
Yeah.
Okay, good.
And then you take that to the 12th to get the yearly growth factor.
So this whole thing now is the
Yearly growth.
annual, yearly or annual growth factor. Okay.
And then I took that to the 7th to get the 7-year growth factor.
Okay. Nice.
And then multiply that by the initial, which is the 10,000.
And if it's a growth factor, we multiply it by an output to get the next output, right? We multiply it by the output. You're going to take 10,000 times the 7-year growth factor, and what do you get?
28391.13.
28391 point what?
I got 0.13. I kept the decimals the whole way through, so might be a little different.
Agree with that, everyone? Okay, now watch this. This is cool. One last thing. So did you catch that? So this was the monthly growth factor, 1 plus 0.15 over 12. To the 12th is the annual. To the 7th is the 7-year. Okay, so watch this. Get rid of this here. So what if our APR was R, and we're going to compound n times per year? Okay? Then we take R first and divide by n, right? So R is the APR as a decimal, and n is the number of compoundings per year. And then we would add 1. And that would be what? That would be the 1 compounding period growth factor, right? 1 plus R over n would be the 1 compounding All right, don't pack up and tune out. So this is the one compounding period. But if we want the annual growth factor, what do we do? Aaron? Raise it to the n. So this is the one compounding period. Growth factor. Raise it to the n, and we get the annual growth factor. And so say we want it for t years. Then what? Raise it to the t. And that whole thing is the t-year growth factor. And then we're going to take the initial amount times the t-year growth factor. Initial. To get the final amount after t years. Some of you have learned this compounding formula before. But notice, the formula is all about growth factors. You didn't know that though. It's just a bunch of growth factors. It's the per compounding unit growth factor, 1 plus r over n. To the n is the annual growth factor. To the t is the t-year growth factor. Multiply it by p gives you the new value t years later. Web work for Thursday and